today we're going to be looking at the wireless transmission side of things. First we'll be looking at just general overview of wireless technologies and then on to the nano beams, and then looking at the higher end wireless solutions, which we've got Steve from AMG Systems here, who's one of our partners for the higher end wireless side of things. So my name's Nathan Garner. I'm the Technical Pre-Sales and Projects Manager here at Dynamic CCTV, and we've also got Steve Dunning here with us today, who's kindly taken the time to run through some of the AMG wireless options as well for our customers. So we'll get started. If you have any questions, if you put them in the Q&A section on the Zoom side of things, and then towards the end of the webinar, myself and Steve will be able to go through those questions and answer any of them that you have there from the slideshows today. So there's a number of different wireless bands that are available in the UK. So we've got 2.4 gigahertz wireless, which is generally what you see most common, especially with your standard routers and access points for your Wi-Fi. Generally what you see a lot more now, especially more frequently, is the 5 gigahertz band, which has a lot more throughput, but doesn't generally have the same distance when you're using it for your standard Wi-Fi connections in a property. We've also got DFS and TPC, which we're going to take a look at in depth in a separate slide, which covers what these are more in depth and why they're used in the wireless transmission industry. We're also going to touch on 60 gigahertz and 80 gigahertz links, which are also generally protected and licensed for those on those sites where you need to have your wireless transmission protected, or you need to be in a frequency band that has less transmission on and less susceptible, won't get interfered with from other devices in the area as well for those. So firstly with the 2.4 gigahertz Wi-Fi, so this is used for Wi-Fi, Bluetooth within the wireless technology. It was originally used for point-to-point, but it's now generally being replaced by the 5 gigahertz bands. It was mainly used on routers and it's the longest reaching distance, but the range is balanced by the low throughput on the 2.4 gigahertz band within that. And the maximum transmission power is 100 megawatt, 20 dBm on those. And this is an unlicensed band, so you don't need to pay to use this frequency. So this is free for the full band in the 2.4 gigahertz range to use. And there's 11 5 megahertz channels just used in the UK for Wi-Fi within the 2.4 gigahertz band as well. Moving on to the 5 gigahertz, this is generally where the range where you generally see most point-to-point links now, and often you'll see Wi-Fi routers, you'll have a 2.4 gigahertz band and you'll have a 5 gigahertz band. Some are combined under the same SSID, and your devices will then switch between whichever gives your device the best signal at the time. 2.4 can obviously travel further, but 5 gigahertz band, you can almost think of it as a motorway as such, so there's a lot more lanes for the data to pass through, so you have a higher throughput and achieve better speeds with the 5 gigahertz bands within that. And these are split into 3 different sub-bands with different applications depending on what's being used. So within this we have the 5.4 gigahertz band. This is generally what we use with the nano beams. It doesn't require licenses, however because of this, depending where it's being used, it can be overpopulated with other devices within range, so you can actually limit down the bands it's using within that. And there's a tool that will actually scan the area in the vicinity for other devices using similar bands to the nano beams, and you can actually deselect those and use the less highly trafficked spectrum within that. So then you have less issues with interference and less drop in your throughput as well. So these generally used for fixed wireless access points. So this can be point-to-point, which is generally what you use for your wireless bridges, from a transmitter to a receiver. You've also got point-to-multipoint, so you can have multiple transmitter units going back to a single access point on a building, which can be great if you have poles with PEZs mounted to them, for example. So long as from those 3 poles you've got line of sight back to your main access point, you can transmit those 3 locations back to that single unit on your main building to the recorder for live view and playback and recording of those actual cameras. And it would also send the telemetry over the Wi-Fi as well. Now, this is an unlicensed band and you can achieve up to 300 megabits per second. This is in the 40 megahertz channel. The other channels can be more restrictive on the speeds that you can achieve. And generally with the nano beams, even though they can achieve speeds up to 300 megabits per second, the amount that you can actually use dedicated for compressed video CCTV is limited by the actual CPU within the nano beams themselves. So if, for example, you have poor weather conditions, the packet loss between the two units and confirmation of delivery of the packet starts using more CPU within the links, and that's where you can see cameras drop out. So we have actually brought down our recommendations on the maximum number of cameras that you can run over a nano beam set, which we'll cover off as well. And this is where we'd then look at the AMG links as well for that. Further to that, we've also got the 5.8 gigahertz band. So this is a licensed band, so it's appropriately managed and more reliable due to low levels of traffic, especially in built-up areas or where there's already existing Wi-Fi on site. For example, if it was in an area where there's a lot of homes that are transmitting in the 5 gigahertz range, or 5.4 gigahertz, shall I say, for Wi-Fi, it may be that we'd need to look at using more of the licensed bands in this scenario to give you the best reliability of your wireless links. These operate between the 5,725 megahertz and 5,850 megahertz band, known as band C. Maximum transmission power in the UK for this is 4 watts and it's 36 dBm. This would need to be registered with Ofcom in order to use this band, so there would be a license fee for using this version of the wireless transmission on there, but it would give you the protection of others not being able to interfere with your wireless signal in that area within that. Same goes if you do try and broadcast on the frequency without a license, you can be fined in those scenarios, so you do need to check the licensing for that. And this is again link speeds of up to 300 megabits per second, and this is also in the 40 megahertz channel as well. So most equipment generally uses fixed channel numbers between the different spacing between the bands. So between 100 to 145, 49 in megahertz channel increments. So nano beams can use both licensed and unlicensed bands, which is important to know because you can actually set it to a licensed band on the nano beams themselves, and you could actually incur heavy fines for doing so if you don't have the Ofcom license to be able to use that band for those. So the 5 megahertz, that can achieve typically 32 megabits per second. 10 megahertz would be 65 megabits per second, and 20 megahertz would be your 130 megabits per second. To achieve the full 300 megabits per second throughput of the nano beams, that would be at the 40 megahertz on there. But as I said, we then start running into issues with the CPU load with the wireless links on there, which is generally what we take more into a factor. So we generally hit that limit, especially in the bad weather, which we do get in the UK. It does like to rain in the UK, and obviously the snow in the winter as well is where you'd see the issues. So the 5 gigahertz and the use of DFS and TPC. So in the UK, there are regulations on the mandatory use of dynamic frequency selection. So this stops you from being able to transmit in on the same frequencies as radar detection, should I say. And there's also the automatic transmit power control, which limits the power that you can actually use on there. This stops you from broadcasting on protected frequencies, and there's different conformities to that as well. So for the 5.4 gigahertz, it must conform to the IR 2006, and for 5.8 gigahertz, it must conform to the IR 2007 within that as well. Many installers have not necessarily ignored, but been unaware of a lot of the regulations with wireless equipment. There are some wireless units out there that can can be used in other countries that do have the options to disable, or maybe as default have these options disabled, which could then land you in hefty fines from Ofcom or the regulators within there as well. So it's always important to make sure they're set up correctly. And with our pre-configured units and the pre-configured units that we do through AMG as well, these have these enabled on there. If these settings aren't enabled, you can cause interference with Met Office stations, and Ofcom are now actively clamping down on people that are breaching these as well within that. So important to learn from this is don't disable the DFS or TPC in the UK when you're using wireless transmission for those. So now we're just going to touch on the 60 GHz and 80 GHz bands that are available in the UK as well. So 60 GHz is known as V-band and is generally used for point-to-point links. What happens at the 60 GHz range though is you get oxygen absorption issues, I can say that word. So it is more of a short range link with the 60 GHz, but then you are less susceptible to the frequencies of other Wi-Fi sources in the area. Typically the maximum range is 1 kilometre on some of the links, and you can actually achieve up to 1 gigabit per second throughput in your best kind of scenarios without any interference between the two units. Then also got the 80 GHz band, so this is known as E-band. Again, this is generally used for point-to-point links, but you can get rain fade issues at the 80 GHz. So again, this is another shorter range transmission unit. This band is also lightly licensed by Ofcom, so you do need to register with Ofcom in order to be able to use this band. And this can actually give you up to 2 gigabits per second between your links, so it does have a high capacity throughput, but due to the short range, this will be kind of your short throw between two buildings, for example, or where you need to run a lot of data but over a short distance within these. So there's a couple of different wireless technologies. So we've got point-to-point from one point to a single another point. So this is great for example, linking two buildings together. If you have cameras in a remote barn on a farm, for example, and they need to be transmitted back to the main building. Or if you have a pole out onto the car park where you've got an ANPR camera mounted for your client, you can transmit that directly back to the main building using a point-to-point link. This can be a lot more cost effective, should I say, than having to run cabling, especially if you're needing to dig trenches. If it's only one camera and you've got direct line of sight between the two locations, you can use the wireless point-to-point links, and that saves on digging trenches and extra infrastructure needed for running the cables. But as I say again, depending on the amount of throughput you need in or the cable distances, it then may be that you might need to look at something like fibre transmission, especially on really long distances or where you're having to link multiple locations. Generally, it's always better to have a hardwired connection. There's less likelihood of that connection being lost if it's hardwired. Wireless, there are always things there that can interfere with wireless transmission within that. So with point-to-point transmission, there is high capacity available. So you can get up from anywhere from 10 megabits per second all the way up to 2 gigabits per second on your wireless links. And latency between the units is generally relatively low, depending on your signal strength between the two wireless units. If the signal strength is quite low, then you will start getting a delay between two units, and that's where you can start seeing delay on cameras. And so it is important, especially with CCTV, to reduce the delay as greatly as possible, especially for recording and when you want events to come through from alerts, especially for monitored systems as well. So the transmission between the two units can be encrypted, so it is secure and can be tampered with as long as the encryption is set on the links. And for the pre-configured units that we do, the encryption is set to protect the data, especially when it comes to CCTV. You don't want someone being able to gain access to your CCTV network that you've installed for your client. And these generally perform as a transparent bridge, and you do get longer distance transmission when using point-to-point. If you're using point-to-multipoint, which we're going to look at next, that can generally give you lower transmission distances than you can achieve with a single point-to-point link within there. And you can use on the nano beams adaptive frequency modulation, so the units themselves will work out the best frequencies to work on in order to give you the best connection between the two units. So now if we look at the point-to-multipoint, so this is where you can have a number of transmitters going back to a single receiving point. So if you have multiple poles with cameras fitted on site, you can have a transmitter unit, which would be your station. As long as they've got direct line of sight back to your main access point, you can have multiple stations going back to a single access point. With the nano beams, it is a maximum of 3 transmitters going back to a single access point on these. So with multiple links, it can be more cost effective doing it this way instead of having an individual link per pole. For example, if you've got, for example, 3 cameras on each pole, you can have up to 6 transmitting over these back to a single access point. So you can have 2 poles set up, 3 cameras on each pole, both transmitting back to a single access point on the main building to then be recorded on the NVR that you have there. And with the point-to-multipoint technology on the nano beams, these can run up to 300 megabits per second, and this is done in perfect conditions. If the conditions aren't perfect, and obviously, as I mentioned before, with bad weather, this capacity drops on what you can actually achieve on site, and also what else is transmitting in the area as well for those sites that you're looking at. Same with the point-to-point, you can encrypt the wireless transmission between the units so that it is secure on site. And again, these typically work as a transparent bridge, and these allow you to be able to bridge multiple locations back to a central point. So the initial configuration of the nano beams, so each unit has a default IP address of 192.168.1.20. If you have both units plugged into your network at the same time, both units are on the same IP address, so they would conflict with each other. So it's best to plug one in at a time until you've got one unit set as your access point and one unit set as your station, with different IP addresses for the units on there for those. For point-to-multipoint configuration, again, we do sell these pre-configured, so we can pre-configure the units before they're sent out to yourselves. So when you get them to site, these can be already configured for plug and play, so you can get site, saves installers and engineers a lot of time on site and not having to set up the actual wireless links. It can work as a plug and play scenario, as long as we have either the IP details for the network or the IP addresses that you want to be configured on the units. We can do those. We also do that for the point-to-multipoint as well within those. And John has asked, do you require a PoE switch with each unit? So with the nano beams and for the actual power of each unit, they come with their own PoE injector that runs off non-standard PoE. So it has an injector that will take your LAN connection either to your network or your camera switch, and there's a PoE output which would go into your nano beam link, and it's a power supply that would go connect to the power on site to give you the PoE on there. So there are some limitations to take into account with nano beams. So there is a maximum recommended of 6 cameras per link. In perfect conditions, without any bad weather, which in the UK is near enough impossible for any length of time, what will happen is the If it's raining or snowing or anything like that, the transmission between the two links, the CPU time would start going up because it has to confirm that packets have been delivered or to resend packets if they've been missed, and that starts using more of the CPU up in the nano beams themselves to confirm those packets, and that's where you can start seeing links drop out or cameras drop off the links because the units are working harder and harder to be able to confirm those packets have been delivered correctly. So it is a maximum of 6 cameras per link on the nano beams. There's no more than 3 stations, which would be our transmitters, going back to a single access point. And you do need to have direct line of sight between the links. So if there's any foliage, bushes, or anything like that between the links, this can have a dramatic effect on the performance of the units and actually can stop them working altogether. So it is important to take that into account. There is also the issue of packet loss during bad weather. So this is where we've capped the maximum limit on the nano beams as 6 cameras per link, and you can have no more than 3 to 4 links daisy chained. Any more than that, you can get a lot of delay using wireless in that kind of scenario, or you can actually get cameras dropping on and offline within those. For higher end requirements, we partnered with 𝐂𝐸𝐸, who we also deal with for a lot of our fibre side of things. And so I'll hand over to Steve now, who'll be able to introduce himself and obviously the 𝐂𝐸𝐸 team as well. And he's got some slides to run through on the higher end wireless that we can supply from 𝐂𝐸𝐸 as well.
Thank you, Nathan. Okie well, thank you, Nathan, for inviting us on here, and thanks to Dynamic CCTV. It's a very good presentation, that, Nathan. And I was conscious that when we did my sort of selection of slides and so on, that I didn't want to kind of repeat too much of the technologies you were talking about. Although I will say that a lot of the technologies are obviously the same throughout the frequencies of wireless and point-to-point links and so on. So majority of what Nathan's already discussed is relevant to our links also. One of the biggest benefits of our links from the links that Nathan was discussing is their processing capability and the throughput capability, which is a little bit greater, gives you a bit more flexibility and a little bit more control in how you distribute your wireless CCTV systems and so on. So I shall just jump into our slides format now. And yeah, so the build quality of these products are pretty outstanding. They are all built to design to be sort of really quite robust and weather resistant, as you would expect. So we start with our AMG 𝐂𝐸𝐸7OFs. These are sort of pre-kitted as a point-to-point link. So you buy it from Dynamic as a complete link. These will give you up to 6 kilometers of range with a reduced throughput. For the further the range you apply to the link, the less megabits per second you can actually put through that link. But as Nathan pointed out earlier on, the links we were talking about before, maximum throughput of 300 megabits per second using the 40 meg frequency on the division. We can actually go up to 80 megahertz, which gives us that next step up on the bandwidth to 450 meg. As a complete throughput end to end, I mean, obviously we're talking CCTV, which tends to go in just one direction. These links can cope to just short of 900 meg, so they're quite capable. They are quite capable. Another important thing about our links is that we have an official IP rating on the links, which some of the lower cost links tend to not have whatsoever. So if you need a link that has to have a specification that includes an IP rating, ours are IP66, which we all understand the IP ratings in our industry. When you buy the link, so it's pre-configured as a point-to-point link, so you literally would need to just install that link, point the units at each other, and you would have an established link. Nice thing about the links are also there's a LED indicator on the back of them, which gives you signal strength. And there's some other little features that will enable you to have a nice, easy, simple installation. And coming from sort of years ago, the installation trade, it's the easier things to install, the quicker the job goes together, and the more money you save on the outcome. These will come with their own PoE injectors. The 24 volt supply, so we call this a passive PoE as opposed to our conventional 48 to 56 volts PoE. And I don't want to class these as full industrial, because we would comment the full industrial as being -40 to +75 degrees C. These are what we call light industrial because they only go up to plus 65 degrees C, but they're more than enough to cope with any sort of external temperatures. They're not going inside another box to generate that much higher temperature that we can see when things are operating within an additional sort of metal cabinet or adaptable box or whatever. So these are sort of, you know, on the outside of a building. As options of mounting, they come as pole mount as standard, but we can do a wall mount bracket, as you can see underneath there, which just bolts to the building, and then you clamp the device onto the side of the pole that creates that wall bracket. So that's the sort of point to point offering. It's quite simple, it's quite straightforward, but very, very effective. If you wanted to do a point to multi-point, we have this 90-degree option, which is the as it says there, the AMG 𝐂𝐴70F-30-90, and the 90 denotes to its antenna degree of field that it can collect data in from. We do wider options, but then we're starting to break down into more complex offerings, but and generally with external antennas rather than built-in antennas. But it's a nice, easy, straightforward method of bringing in 2, 3, 4, possibly even 5 connections, wireless connections within a 90-degree field of view from the base, from this actual base unit here. Yeah, so this is realistically, would only use this for a multi-point collector, if you see what I mean, rather than trying to create a point-to-point with 2 of these. It just wouldn't make that much sense, and you get a much reduced distance within the range. As the degree of antenna increases, so your focal array, if you like, if your focal plane increases in width, the range of that capability decreases equally. So if you think about the narrower the antenna, so 6, 11, 12 degrees, the further the range, the wider the antenna, the shorter the range. It's quite a simple kind of payoff, and it's unfortunate that it is the case, but that's the limitation on the power ratings that we have under the free license in the UK. Again, IP66 rated, -40 to +65, and they come again with the passive PoE injectors. If you want to do any supply to these with the standard PoE switch, we do a nice little product which converts standard PoE to passive PoE. So you disregard the PoE injectors that come with this product. You have your PoE switch. You use our little 48 volt to 24 volt PoE converters, which means you don't need to add another power supply to power the PoE injector. You see what I mean? You're going to get all that power from the PoE switch itself. And these are all fairly low powered devices, typically AF, so sort of 15 watts, certainly no more than that. If we were to create a bigger base station with more flexibility, with antenna connectivity, which can give us a range up to 20 kilometers, we would move on to our ME version. We don't sell too many of these. People have now sort of stepped back from trying to flood spaces with wireless transmission, especially with CCTV, for exactly the points and reasons that Nathan pointed out. Bad weather, snow and fog and all the rest of it does have an effect, although with better processing capability and a higher throughput capability, then those effects are reduced dramatically, but there's still a risk. And depending upon the level of security of your CCTV system would depend, you know, how you sort of look after those risks and mitigate them by either shortening the links or going onto a sort of a hybrid-y, hardwired, fibered, and then linked system to protect yourself from system failure. We just mentioned about external antennas. So these sort of give you array options, and again, sort of diminished distance with the wider the array as far as the pickup is concerned on the product. So we do even down to a 360 degree, what we call an omni antenna. So you'll see that distance there is reduced to 3 kilometers, but with a 3-degree directional dish. So they look like sort of a basic satellite dish kind of thing as we look. We can get up to 20 kilometers plus out of those, and then the different sector dishes in between 60, 90, 120 degree again reduces from that overall distance. But again, simply think about the wider the array angle, the shorter the link will be in terms of capability. All right, so as far as installation is concerned, again, this is the standard point-to-point link. We can break these down to be just single clients, so a client back to a base station, but the kind of, the signal path is still going to be about the same. So there's an image there that gives you a mind's eye of how that data's dispersed out, or how that channel's dispersed out through the atmosphere, from a central point of the device itself, from the client itself, out towards what would be either a receiving client or a base. And you can kind of see where if there were trees and other buildings in between things, where we could have quite an infringement upon the data path. Now, it's not just a parallel channel that gets sent between the devices. It sort of does flood out quite dramatically, and we'll see that even more when we move to the 90-degree product. But as far as installation is concerned, the bracket on the back of our SkyWave devices gives you a little kind of image of the angle that you can mount that device at. So it'll tilt backwards and forwards on its pole mount. Obviously, the left and right positioning would be, the sort of slacken off the clamp on the pole and then just twist it around a little bit. And then we've got the coverage of the signal detectors, LEDs on the back of the units to make sure that everything's aligned nice and fully. So we call this sort of a full azimuth adjustment. A lot of the lower cost wireless links don't have a tilt up and down adjustment. They're just flat brackets that clamp straight onto a pole. So you're kind of hoping that your pole or your wall bracket has that sort of tilt up and down adjustment to be able to get your different heights and pitches between the transmitter and the receiver of the wireless link. Now, a quick look at the 90-degree version. As you can see, the array path is completely different, and now you can probably quite quickly understand why there is a reduced distance within that product as far as capability is concerned. The mounting bracket is still the same. We've still got that tilt up and down adjustment with the degrees markings on the side of the bracket there. And again, your left to right angle will be controlled by the clamp around the pole itself. So nice, easy, compact, straightforward alignment devices there that can really help you get the maximum link capability out of your units. So there's a little drawing of how we sort of put together bits and pieces like this using a standard point-to-point link. We can open that up to 450 meg. This is just like a 1 kilometer example. So this is the pre-designed point-to-point link. This is the 8870-06-2. It's not an 02, it's -2. My mistake. So we're collecting up a bunch of cameras into an Ethernet switch. We're powering up the transmitted link there, if you like, across our open space, back into another little switch. So we're bringing those cameras in, connecting some more cameras and taking them off into a local control room. This could be over Ethernet or standard copper or even fiber back between the control rooms and the bases, depending on how your topography lays out. But how do we go about converting or looking at a system that gives us a point to multi-point situation? So we've got here an example of a collection on a multi-point situation. It's bringing in a point-to-point and point-to-multi-point scenarios. So again, when we assist people with designs of systems, we always look at bit rates for camera types and camera quantities. But not only that, we take into consideration how the front-end system actually copes with all that kind of data. So some front-end systems use their recording servers as a rebroadcasting server. So we only really take a couple of streams from each camera, regardless of how many clients are attached to the system and viewing and recording and playback and so on and so on. Other simpler systems, every time you view a camera, you're pulling another stream from the camera as well as the recorded stream. So if there's 3 or 4 client viewing on there, as well as a video wall, you can soon see how each camera can suddenly be having to provide 2, 4, 6, 8 streams of different resolutions of images, which loads up the link between your building and the remote buildings and so on. And before you can quite quickly run out of capability within the system. So when we're doing a design, all these things are taken into consideration, and we'll sort of advise as best we can, depending upon the requirement as we're going forward. And from this multi-point collector down at the bottom right here, we can then bring this into our new control room. So that would give us a nice situation. We've got point to multi-point, we've got point to point, all coming back through a collection point into a nice little control room there. Okay, so key features and benefits about the SkyWave links from AMG. very, very important one here. So corrosion resistant casing. So, you know, if we're up and down promenades on the seaside or whatever, yeah, we're not going to worry about everything going chalky and white and just disintegrating over a short period of time with the sea salt air. We have the IP66 rating, which is extremely important, especially in the UK. Globally, you know, some people may not be too worried about that sort of thing, especially in warm, dry climates and so on. But certainly here, where it gets very wet, a lot of the time, we tend to really enjoy the fact that we've got an IP rating there. Fairly compact form factors, so they're not massively obtrusive. They're nice and tidy, neat, compact, you know, without giving up any of the capabilities or the ease of installation and LED displays and so on and so on. Again, yeah, so the LED indicator on the side is really a nice function for alignment. And those incremental settings on the full azimuth adjustment is another great feature of the links. If you've not, if you've tried to put links in before that don't have those adjustments on, you know, especially when you're looking at sort of a kilometre, trying to link up a kilometre, it really can be quite time consuming to get the maximum connectivity out of those. The point-to-point link, which is part of Dynamic CCTV Cell, is pre-configured. So they're a matching pair. So you shouldn't really get any crosstalk from any of the other 5 gig equipment that's kicking around in that installation area. And you know, they come with PoE injectors, so everything that we have comes with its own PoE injector and mounting kit, except the wall bracket option, obviously, because that's an additional option there for those. And we offer a 3-year warranty across our wireless links, so that's a 3-year back-to-base repair warranty. Okay, so just a quick touch on 𝐂𝐴MG, I guess. We are a UK manufacturer. We do all our own hardware and software design in-house. This is sort of across the spectrum of all our product range, and it's typically all Ethernet based, industrial and commercial switch products, fiber connections and media converters and so on, as well as the wireless links. We've been doing this we've been in this industry for getting on for 30 years now. Obviously our start in fiber transmission was with the analog, the old analog days of a camera or a PTZ camera, audio and so on, so the old analog stuff. We have our own UK technical support team. All repairs are done in-house down in Biggleswade at the office in Bedfordshire. So we're all nice and neat and local. We, you know, with our full support packages and so on. And we also now have what we think has been our industry-leading warranties. It's 3 years on our commercial stuff and the wireless links, but on our industrial products, we offer a lifetime warranty, repair warranty, back-to-base repair warranty for those, which you don't need to pay anything extra for. That's just how they come. That's just how they are. Okay, thank you very much for your time. If you've got any questions, please fire them through, and we'll do our best to resolve those for you as easily and simply as possible.
And that was great, Steve. Thanks for doing that for us today. And obviously there's a lot of benefits there with using the AMG wireless as opposed to the standard kind of nano beams and stuff that we do. But there are sites out there that are more complex, or where there can be a number of different solutions that you can go for on those sites. So at Dynamic CCTV now, we have a dedicated technical pre-sales team. So if you are looking at a system and you want to check your requirements or whether or not it will work in the manner that you need it to meet the client's requirements, you can get in touch with our technical pre-sales team and they'll be happy to go through any of that with you. Those details are on screen there now. Within that, and obviously for larger systems, we also get our partners AMG involved, who can help us put together fiber transmission and also the wireless transmission as well for larger systems where that's needed. So I think that's all of what we had planned to cover today. So if you have any questions, if you put them in the Q&A section, I know there's been a lot of information that we've gone through today, or alternatively, you can send an email to the address that's on screen there. Myself and my colleagues will be able to answer those off. I know there was 1 or 2 questions that came through, which I think we answered as we went along. If you're leaving the webinar now, when you close the webinar out, you'll be redirected to a feedback page. I'd be really grateful if you could give us any feedback on the webinar that you have, good or bad. It always helps us to improve these for our customers, and we can make any improvements or anything going further forward as well. for that. So thank you for joining us today, and thank you to Steve from AMG Systems for taking the time out to co-host this webinar, and I hope to see you on the next one again, and another one with Steve as well, hopefully.
Yep, thank you very much for your time. Much appreciate it, and yep, I look forward to the next one.
Thank you, Steve.
Thanks,
And
Nathan.
thank you everyone for joining as well. Thanks. Bye.
Okay, take care. Bye-bye.